Information gathering is one of the most important steps when it comes to hacking or penetration testing. If you think of it, you can't really gain access to a system if you don't have enough information about it. So for example, let's say you're connected to a network and one of the devices connected to this network is your target. Now for you to hack into that target, first you need to discover all of the connected clients to this network, get their MAC address, their IP address, and then from there try to maybe gather more information or run some attacks in order to gain access to your target. Now there are a number of programs that will do this for you. Examples are NetDiscover and Nmap, which do this job really well. So in this lecture, we'll start with the simpler one, which is NetDiscover, and see how to use it to quickly map the network we're connected to. And in the next lecture, I'm going to show you how to use Nmap to gather detailed information about all of the clients connected to the same network. So I have my Kali terminal in here, and if I do ifconfig, you'll see I have ETH0, it has an IP address, and like I said, this is the virtual interface created by VirtualBox when we set the Kali machine to use a NAT network. Now I also said that this NAT network behaves exactly like an Ethernet network, and as far as the Kali machine is concerned, it thinks that it is connected to a real wired network, and as you can see in here, it's telling me that wired connected. Now I have my virtual Windows machine right here. It is configured to use the same NAT network as the Kali machine. Remember, we're still in the network hacking section, so both you and the target machine need to be connected to the same network. So as far as these two computers are concerned, they think that they are connected to the same network. So what I want to do right now is use NetDiscover and see how we can use it to discover all devices connected to the same network. Now the method that I'm going to show you will work exactly the same whether you're using it against a virtual network like I'm doing right now or against real network, and even if your target is a Wi-Fi or a wireless network. So all you have to do is type the name of the program, which is NetDiscover, and then type -r to specify an IP range to search for. This needs to be a range that can be accessed by you. So right now you can see that my IP is 10.0.2.16 and I can only access IPs on the same subnet. So IPs on the same subnet start at 10.0.2.0 and they would end at 10.0.2.254 because 254 is the last IP that a client can have. So my range is going to be 10.0.2.1 and I want to search for clients that might have an IP of 10.0.2.1, 10.0.2.2, 10.0.2.3, all the way up to 10.0.2.254. So instead of manually typing all of these IPs, I can just type over 24 and NetDiscover will automatically know that I'm trying to search for all of the IPs that start at 10.0.2.1 and end at 10.0.2.254. So this is a way of specifying an IP range for the whole subnet. So if I hit enter now, you'll see that NetDiscover will show me all the IPs of the devices connected to the same network, and note that the first three parts of the IPs are always the same because they are on the same subnet. And I also have the MAC addresses of these clients, and NetDiscover is also attempting to guess the device vendor. Now if I press Q, this will quit the program, and right now we have a list of all the connected clients to the same network. Now like I said, you can also use this method to discover clients connected to the same Wi-Fi network. The only thing is right now, if I do ifconfig, you can see that my Kali machine does not have a wireless adapter. It's not connected to a Wi-Fi network. And like I said before, you cannot access the built-in wireless card from a virtual machine. Therefore, if you want to do this or run any of the wireless attacks that we're going to see in the future against a real computer in a real wireless network, you're going to need to use a wireless adapter. Now, I'm going to include links in the description that will help you pick a good adapter that works with Kali Linux. But right now I actually have one, and I'm just going to connect it and use it just to prove to you if things work on the virtual machines connected to the virtual network, they will work exactly the same against a real network with real machines. So I'm going to connect my adapter now, and if I do ifconfig, it's still not showing up. So I'm going to connect it from my devices, USB, and click on the adapter name. And let's see if it shows up now. Perfect. As you can see, I have an adapter now called LAN 0. And what I'm going to do is I need to connect this adapter to a Wi-Fi network first before I can discover all the connected clients to this network. So I'm going to go to my network manager. I'm going to click in here, and you want to click on select network. And as you can see, automatically now it actually connected to a network. But in your case, you'd want to select a network and click on connect, and then it will ask you for the password. So now I'm actually connected, and you'll see if I do ifconfig again, right now LAN 0 has an IP address. So this means that it is connected to a network, and this means that we can use it now with NetDiscover. So again, I'm going to use the exact same command that I used before just to show you and prove to you that if this works against virtual machines, it will work against real machines. And the only difference is going to be the IP. So I'm going to remove this IP. And as you can see right now, my IP is 192.168.1.8. So therefore, the range that I'm going to look for is going to start at 192.168.1.1. And I'm going to leave the over 24 here because this will tell NetDiscover that I want to start at 192.168.1.1 and finish at 192.168.254. So if I hit enter now this did not work, and I know why. In order for this to work, you actually have to disable the NAT network. So to disable the NAT network, we're going to go on devices, we're going to go on network, and we're going to uncheck the connect network adapter. So now once done with this, if we just run the exact same command again, as you can see, it's discovering all the connected clients, all their IP addresses, all their MAC addresses, and it's guessing the manufacturer. And you can see it's also discovering some Apple devices here. So as you can see, it's working perfectly using the exact same command. Now I only did this just to show you that if things work against virtual machines and against virtual networks, then they will work against real machines, because these virtual machines and virtual networks are modeled over real machines. And as far as the machines are concerned, they actually think they are real computers and real machines. The second program that we'll use for network mapping is Nmap. Now, in the previous lecture, we used NetDiscover, and we've seen how nice it is to quickly discover all the devices connected to our network, see their MAC address, and maybe get the vendor. Nmap takes scanning to a whole new level. It might be a little bit slower than NetDiscover, but it will show you much more information about the target. So you'll be able to see the open ports, you'll be able to see the running programs or the running services on these open ports. You'll be able to determine the computer name, the operating system running on that computer. If you're in a network, you'll be able to discover all of the connected clients. You'll be able to bypass security, bypass firewalls, and so much more. Nmap is actually a huge tool, and there are books and complete courses done just to teach Nmap. The Nmap book would actually be a really good read once you're done with this course. Now, because this tool is huge, we're not going to be able to cover all of its uses, but in this lecture, I'm going to show you the basics of this tool, how to use it to discover all the connected clients and see useful information about them, and we'll actually use it more when we get to the gaining access section. We're actually going to be using ZenMap, which is the graphical user interface of Nmap. So to run it in terminal, you just have to type ZenMap, or you can find it under your applications menu. Now, as you can see, it has a very simple interface. The first thing that we see is the target input box. In here, you can put your target. You can scan any IP that you can reach, whether it's a personal computer, whether it's a server, whether it's an IP for a web server, for a website, for example, that you want to discover all the open ports and all the running services on it. Or, like what we're going to do right now, we can put a range similar to what we did with NetDiscover, and it'll scan this whole range, discover all the live IPs, all the IPs of the connected machines on the same network, and display information about them. Now we'll have a look on how to scan servers in the gaining access section. So for now, since we are still in the network hacking section, we're gonna put a range to discover all the connected clients and see useful information about them. So right now I'm actually connected to my wireless network. That's why I'm gonna specify the whole range on that network, and we've seen how to get that in the previous lecture. So it's 192.168.1.1 over 24. At the bottom, you can see the command. This is actually the Nmap command that will be executed when I hit the scan button. So like I said, ZenMap, what we're using right now, is just a graphical interface that will run this Nmap command in the background and show me the results. So if you know a custom Nmap command, you can put it here, or if you just want to see Nmap in terminal, you can literally copy this command, paste it in terminal, and it'll give you the same results that you would get if you run it here. Alternatively, if you don't really know much about Nmap and its commands, you can use one of the ready profiles in here. So in this lecture, we're actually going to be using a number of these profiles, and we'll see the difference between them in terms of speed and the information gathered. So I'm going to start with the ping scan. This is a very quick scan. It literally just pings every possible IP in the range, and if it gets a response, it'll record this response and it'll show me the devices that gave me a response, which means that these are the devices connected to the network. Now, a lot of devices do not respond to ping requests even if they are alive, so the list that you'll get in this scan might not include all the devices connected to your network. Now, once the scan is done, as you can see, we can see the list of all the connected devices in here. And in here, we can also see the MAC addresses for each of these devices. We also can see the vendor. So for example, we can see that the device at 192.168.1.1 is a Cisco device. This is actually my router, and it is made by Cisco, so this is correct. So we can go ahead and start looking for exploits in this device. We can also see the 192.168.1.10 is a HTC device, and again, this is a HTC phone. This is correct. And since it's HTC, then we know that it's probably running on Android. So as you can see, we're getting more information about the connected clients. Again, we can see the 192.168.1.12 is an Apple device. So it could be a phone, a tablet, or a Mac. We can see the next device is a Dell. So again, it was a very quick scan, but as you can see, it still gave us much more information than what we got from NetDiscover. The next scan that I want to show you is the quick scan. Now this is going to be slightly slower than the ping scan, but it's going to show us more information. So right now you can see that the scan is showing us the same information that we've seen before with the ping scan, but it's also showing us the open ports on each one of the discovered devices. So it's able to discover the following ports in the router, and we can see that port 80 is open. This is actually the port used for the router settings page because it runs on a web server, so this is correct. Again, we have our Apple device here that we said it might be a phone or a computer or a tablet, but we can see now it has port 22 open. So this is a port for a service called SSH, which is designed to allow remote access to the system it's running on. Again, if you go on all the other devices, you can see all the open ports and the services running on each one of these ports. Now, in the next lecture, we'll build up on this. We'll see how to gather even more information, and you'll see how important information gathering is, because we're going to use the gathered information to hack into an iPhone that is connected to the same network. Now, in the previous lecture, we had a quick look on ZenMap and how it can be used to gather information. So in this lecture, we'll build up on that. And the main scan that I want to show you right now is the Quick Scan Plus. This scan takes the Quick Scan one step further. So first of all, it'll be slower, but it's going to show us even more information. So first, we're going to be able to see the operating system running on the discovered devices. We will also be able to see the device type, whether it's a phone or a laptop or a router. And we'll be able to discover the program and the program version running on the discovered ports. So before, for example, we were able to discover port 80 is open, but we didn't know what program is running on this port or what version of this program. Getting the exact program version is really helpful when we get to the gaining access section, and you'll see then how we can use that to exploit vulnerable services and gain full control over the computers that have these services installed. Now, straight away, when you look at the results, you'll see that we got much more information than all of the scans we ran so far. So the first thing you'll notice is the icons beside the IPs of the discovered devices. These icons represent the operating system running on these devices. So right now we have the operating system for all of the connected devices. And now it's showing us the programs running on each of the discovered ports and the versions of these programs. So for example, if we look at the 192.168.112, the Apple device, on the last scan, we knew that port 22 open and we knew that SSH is running on it, but we didn't know what version of SSH was running. Right now we can see that it's running Open SSH version 6.1. So we can go on Google and look for exploits and vulnerabilities in this specific version, and we might actually find something. We'll actually talk more about that in the gaining access section. Now, if you look at the device type, you can see that it's a media device, it's a phone. So before, we knew this is an Apple device, but we didn't know whether it's a tablet, a phone, or a MacBook. Right now, we know that it is a phone. It's also discovering that it's running Apple iOS 4, 5, or 6. Now, it's actually running a newer version of iOS. I'm not entirely sure. I think 9 or 10, but still, it's close enough. It's telling me that it's an Apple. It's telling me that it's a phone, it's running iOS, so this is really, really good. Now, if we go to the next device here, the 192.168.120, this is a Linux device, and when we ran the quick scan, we were able to identify port 80 and port 49152 open, but again, we didn't know the program running or the service version running on this port. So right now we know it's Apache HTTPD 2.2.22. It's running on Ubuntu. So again, now we have the operating system, the exact version of the service running. So we can go and look for weaknesses and exploits in this specific version. And this port, we didn't even know what service was running on it. Right now we know it's a UPnP service. And the server is MediaTomb UPnP. We have the exact version again. So again, we can go ahead and look for exploits in these specific versions. And if we discover any, we'll be able to gain full control on this computer. Again, if we go down to the 192.168.122 machine, we can see that it's running a Microsoft HTTP API on port 5357. You can also browse by the services. So from here on the left, if you click on services, you'll be able to categorize the discovered clients based on the services. So if we click on HTTP, we'll see all the clients that have a HTTP service running. If you click on SSH, we can see the Apple device here. It's the only device that has a SSH service running. So let me actually show you a quick and fun example. If we go back here to the hosts and go back to the Apple device, the 192.168.112, as I said, we know it's a phone, we know it's an Apple phone, we know that it has an SSH service installed on it, running on port 22, and we know that SSH is a service that allows you to remotely execute system commands on the computer that has the SSH service installed. Now, obviously, before you can use this service, you have to use a username and a password. Once you authenticate, it'll allow you to execute system commands remotely on that computer or on that phone. Now, by default, iOS devices do not have an SSH server. Usually, when you jailbreak the phone or the device, it'll automatically install an SSH server, and the password for that server is set to Alpine by default. That's ALPINE. Now, since we know that this is an iPhone and it has port 22 open with Open SSH server, we know that this phone has been jailbroken. Now, since the phone is jailbroken, we know the password to log into SSH is Alpine unless the user changed it. Now, most users do not even know about this, and even the ones that know about this, like myself, are too lazy to change it. So it's always worth a try if you discover a phone like this in the same network. It's always worth a try to go and try to connect to it with the default password. So I'm just going to go to my terminal and I'm going to try to connect to this phone using SSH. So I'm going to type SSH root, which is the username for the admin in Linux, at 192.168.112. This is the IP of the phone. I'm going to hit enter. It's asking me if I should trust this connection. I'm going to say yes. And now it's asking me for the password. And like I said, when the phone is jailbroken, the password is set to Alpine. So I'm going to type ALPINE. I'm going to hit enter. And as you can see, I logged in as root. So right now I have the highest privileges on the phone and I can do whatever I want on the system. And now we can use system commands to completely control the phone. Now this is a little bit ahead of time. We are still in the network hacking section. So don't worry too much about this. We'll talk more about it in the gaining access section, but it's just a quick example that I wanted to show you of how powerful information gathering is, because we literally did not exploit anything right here. We just relied on the information we gathered and we were able to hack an iPhone that is connected to the same network as us. Now, like I said, Nmap is a huge tool. I highly recommend you go ahead and try the other profiles in here. And like I said, once done with the course, I think the Nmap book would be a really good read. We'll also use Nmap much more in the gaining access section, and we'll see how we can use this information to gain full control over the computers using code execution vulnerabilities and so on. But in this lecture, I just wanted to give you a quick overview, and we'll build up on this as we go through the course.